Welcome back to Izzo Math, and if you saw the last video, we're just going to pick up here on some trigonometric identities. We want to make sure that we understand why these things are true, and they're not any voodoo or black magic. They actually make sense, and you don't have to just memorize them. You can make them make sense, and it will make it easier to recall them in your memory. Okay? That's where I stand on it. So let's look at this one. This identity here. From the last video, we showed that cosine squared theta plus sine squared theta equals 1. Just simple Pythagorean theorem in the unit circle gives us cosine squared plus sine squared equals 1. Well, we can do anything we want to a math equation as long as we do it to both sides. That is, I could divide both sides by cosine squared theta. 1 over. And this immediately gives us the identity cosine squared divided by cosine squared is 1, plus sine squared divided by cosine squared is tangent squared. Gives us another very important identity here, that 1 plus tangent squared equals 1 over cosine squared theta. So that does it. Very simple to get that identity. Let's move on to the next one. Here we have cosine of theta plus pi equals negative cosine theta, and a couple more there. Let's draw the picture. First, let's pick an arbitrary theta here. Let's say that's theta. Now, it's very important when you do theta plus pi that you understand that pi is a rotation of half a circle, or a 180-degree rotation. So it actually puts us back on the same line. That is, so if this is theta, from there to there and on the same line is going to be theta plus pi. Okay? So it puts us on the same line. And if we look at our cosine value here, and let's go ahead and draw these triangles. Draw that triangle and draw this triangle. Okay? So from geometry we know that this angle equals that angle. And we know we have right angles here and there, so we know we have two similar triangles, and because we know that the length of the hypotenuse here is equal to the length of the hypotenuse there, we actually have two congruent triangles. So this side here is the same length as this side. So that but this side here is cosine of theta. Okay? And this side here is cosine of theta plus pi. Okay? So, and we know so they're equal in magnitude, but we know that this is the negative direction, opposite of this side, so it equals negative cosine theta. Okay? So cosine of theta plus pi is a negative cosine theta. Sine of theta plus pi, I think we can use we can just jump right to it here. Same argument. That side is equal to that side in magnitude, but this is sine theta. It's positive. This is sine of theta plus pi, and we know they're equal in magnitude, but they're opposite in direction. So this one is a positive, that one's negative, so this thing equals a negative sine theta. So that gives us these two. And now for tangent, this is the easiest one. Tangent of theta plus pi equals tangent of theta. Okay? Well, you just look. The tangent is the slope of the line here. So the tangent of theta is going to be when you rotate the theta, draw your radius, and find the slope of that line. Okay? Well, when you rotate the theta plus pi, you find the slope of that line to find its tangent. Well, they lie on the same line, so of course they have the same slope. So that proves that one. And let's see, do I have one more? How are we looking? 5:20, we have plenty of time. Cosine of theta plus 2 pi equals cosine theta. Let's look at that one. So let's draw, say here's theta. Okay? And so that's going to be cosine theta. Well, oops, not plus. Cosine theta, comma sine theta. That's going to be the coordinates. Okay. Now, what if we look at theta plus 2 pi? Note that the unit circle, that 2 pi is just a trip around the unit circle. So if this is theta, theta plus 2 pi is going to be, so you go, let's go all the way around. There is 2 pi. And then an additional theta there gives me my 2 pi plus theta. So 2 pi plus theta lands me on the same point. Lands me on the same point there. So the cosine of theta plus 2 pi is clearly equal to the cosine of theta, because when we're looking at this in terms of this unit circle, all we're really interested is where we land on the unit circle. What is the x coordinate and the y coordinate? Okay? If I go around theta, here's my x coordinate and my y coordinate. Well, then if I go around 2 pi plus theta, I still land at the same x coordinate and y coordinate. Thus we have that cosine of theta plus 2 pi equals cosine of theta. Okay? Similarly, if we go around 2 pi, an additional theta, again we land at the same point, so that's going to give me the same y coordinate, gives me the same sine. So sine of theta plus 2 pi is just sine theta. So these 2 pi's are just a trip around the unit circle. Okay? So tangent of theta plus 2 pi. So again, if I go around 2 pi and then an additional theta, I'm still at the same end point here, and so the slope of my line, let's see, the slope of my line here is still going to be the same. That is sine over cosine will still be equivalent. The y coordinate over the x coordinate. So tangent of theta plus 2 pi is indeed equal to tangent theta, because we have the same slope. Again, I ask you to try to understand these identities so that when you need to recall them, whether it be on a test or in calculus next semester or whenever, when you need to recall them, that it's not so much of just trying to purely memorize something, but it's something that you can draw some pictures and make things make sense. And that's what math is really all about. So I will see you in the next video. Have fun. This trigonometry is some good stuff.